Bonjour. So today we will do one small topic in the book, again from this chapter, chapter 1, which is called ordre de grandeur. In English, order of magnitude. This term means to take the approximate value of a number closest to the nearest power of 10. It means you're doing a really rough approximation. This is explained how to do here in just this, see this page 12 of the book, and it is explained here, ordre de grandeur de nombre. There are two ways of calculating it, like this or like this. So we are ignoring this because that is really not very common. This is the common way of calculating the order of magnitude of a number. So today's entire video is about this part, that one sentence and this one sentence, and this we will ignore. Okay, so ordre de grandeur, order of magnitude, a way of approximating numbers for comparison purposes. What do you mean by comparison purposes? So let's say I ask you, how much bigger is the planet Earth, our planet, as compared to a tennis ball? Now, you're really not interested in an exact answer. You're interested whether it is a million times bigger, whether it is a million times bigger, or whether it is 10 times bigger. It really doesn't matter that it is 1.6 million times bigger than a tennis ball. I'm just pulling out numbers. I really don't know how much bigger is the diameter of the Earth as compared to the diameter of a tennis ball. But you get the idea. It is to compare two numbers which are very different. So that is the purpose of figuring out the order of magnitude of a number. You'll understand as we go along. So an order of magnitude of a number is a very rough approximation. That is an approximation to the nearest power of 10. That is the nearest multiple of 10. So, suppose I have the number line where I have 0, 1, 10. And then the next power of 10 is way off this side, which is 100. No? 0 is a power of 10. 1 is a power of 10. 10 is a power of 10. 100 is a power of 10. Between 10 and 100, there are no powers of 10. Correct? So, all numbers that come between 10 and 100, which in this drawing will be way off to the right there, will either be equated to 10 or to 100. Similarly, all numbers between 1 and 10, that is 10 to the power 0 and 10 to the power 1, will either be approximated to this number or to this number. So if you take 2, the order of magnitude of 2 is 10 to the power 0, which is 1. The order of magnitude of 6 is 10 to the power 1, which is 10. Why is this going this side and that going that side? Because whichever side it is closer, nearest power of 10. If we go to 9, of course it is closer to 10 than it is to 1. So here I've written it all out. So the way to do it is there are 3 steps. Later on you can just compress it into one step. You can do it straight away, but for reasoning purposes we will take 3 steps. So let's take number A is equal to 2. The first step is to convert it to scientific notation. You have to convert 2 to a scientific notation. So that is 2 into 10 to the power 0. Correct? 10 to the power 0 is 1. No? So 2 into 1 will give you 2. Then we bracket it between two powers of 10. Bracket in French encadré. You'll come across this word in the problems in this. So basically you write down 1 power of 10 this side, 1 power of 10 this side, and you write down your number in between. So 2 into 10 to the power 0 is bigger than 10 to the power 0. 2 is bigger than 1, but it is smaller than 10 to the power 1. So these are two consecutive powers of 10. 10 to the power 0, 10 to the power 1. Then you see which it is closer to. So in this case, obviously 2 is closer to 1 than it is to 10. So then you say order of magnitude is, I have to turn the page, sorry. Order of magnitude is the closer power of 10. So in this case you would write order of magnitude of 2 is equal to 10 to the power 0. An order of magnitude of a number is always 10 to the power something, or minus 10 to the power something, or 10 to the power minus something, but it is always 10 to the power something. Okay, we'll take a few more examples, it'll get clear. So similarly we took point B, which is 6. 6 into 10 to the power 0 is a scientific notation. When I encadre it, when I bracket it between two powers of 10, that is I place it between two powers of 10, then we have 10 to the power 0, it is bigger than that, but it is less than 10 to the power 1. But in this case 6 is closer to 10 to the power 1 than it is to this side. So we write order of magnitude of 6 is 10 to the power 1. Similarly with 9, if we take C is equal to 9, it's exactly similar to this 6 here, and you will again get order of magnitude of 9 is 10 to the power of 1. So this is what we did here. A is closer to 1, so order of magnitude of A is 1, order of magnitude of B and C is 10, which is 10 to the power 1. Okay, so we'll take several examples. Then we'll get familiar. Then I'll give you some homework to do of this, an assignment. And I will do one of the problems in the book deals with this. I will do that actually in this video and explain to you how you have to do it. So prenons un autre exemple. And now I switch to French a little because you will be writing in French. Donc on prend le nombre 23,45. On écrit en notation scientifique 2,345 fois 10 à la puissance 1. Oui, this you can see very easily, 10 à la puissance 1. Donc on encadre entre deux puissances de 10. Ici on a 10 à la puissance 1, ici on a 10 à la puissance 2. So what we are telling here is 23.45 is bigger than 10 and is smaller than 100. Correct? Yes. So then ordre de grandeur de 23,45 est 10 à la puissance 1 because 23.45 is closer to 10 than it is to 100. So the number will switch when it exceeds or equals 50. If it has been 50, if this number had been 50, then 50 into 10 to the power 1, 5 into 10 to the power 1 would give us 50, and 5 we consider closer to this side than to that side, and then it would have been 10 to the power 2. We'll take another example. So now instead of writing it top to bottom, I'm writing it left to right. Number, notation scientifique, encadrement is this, and ordre de grandeur, this is the answer. So let's take a number. Here we have 23.45, to 2345.67, notation scientifique. I'm again talking rather fast, but you can slow down the video, you can pause and rewind. Ici on a 2,34567 fois 10 à la puissance 3. This is clear. I mean, I see from your homeworks that assignments you are doing. You're comfortable converting numbers into scientific notation. Now we do the encadrement. So actually, encadrement for positive numbers, you'll get 10 to the power 3 here. This is 10,000. Sorry. This is 1,000, and this is 10 to the power 4, 10,000. So 2,345 is between 1,000 and 10,000, but it is closer to 1000, then it is to 10,000. So the grandeur is 1000, which is 10 to the power 3. Let's take another number, 8267, similar 4-digit number, 8.267 into 10 to the power 3. Again, the encadrement is the same. It is greater than 1000, smaller than 10,000, 1000 and 10,000. So we get, but it is closer to 10,000 than it is to 1000. So we get, or the grandeur is 10 to the power 4. So basically here we are saying 2345 is approximately equal to 1000. Here we are saying 8267 is approximately equal to 10 to the power 4 to 10,000. So these are very, very rough approximations, and it is meant for calculating numbers which are very different, just like I gave you the diameter of tennis ball and the diameter of the planet Earth. Okay, let's take another one. So if you take the number 5, 5 is, if you write in scientific notation, 5 into 10 to the power 0. So then if you do the bracketing, you'll get 10 to the power 0 this side, 10 to the power 1. This is 1. 5 is greater than 1 but smaller than 10. But because 5 is exactly halfway, we choose, like in rounding off, rounding down, rounding up, we take 5 to the higher side. So you get 10 to the power 1. So here we are saying 5 is approximately equal to 10 in when we do or the grandeur. Let's take now a negative number, minus 6.8. So this is minus 6.8 into 10 to the power 0. So here minus 6.8 is bigger than minus 10 and smaller than 1. Is bigger than, yes, minus 6.8 is bigger than minus 10 and it is smaller than minus 1. I'm sorry, you don't see the minus sign very clearly there. I'd use whiteout, so that is minus 1. So it is between minus 1 and minus 10, minus 6.8. Minus 1 is a power of 10, minus 1 is a power of 10 and minus 10 is a power of 10. So this is now closer to this end. So you write it is equal to minus 10 to the power 1. So minus 6.8 is approximately equal to, its order of magnitude is minus 10. Similarly, now we take a number minus 77, you'll get minus 7.7 into 10 to the power 1. So here you'll get minus 10 to the power 2, and here you'll get minus 10 to the power 1, because 77 is smaller than minus 10 but bigger than minus 100, but it is closer to minus 100. So here, or the grandeur is minus 10 to the power 2. I hope you are following. And finally, we take a very small number, 0.0046. It's not finally, it's finally on this page. I continue on the next page, sorry. So here we write it 4.6 into 10 to the power minus 3. So this is 10 to the power minus 3 is the smaller bracket, that is 0.001. 10 to the power 3, 0.001. This is our number, 4.6 into 10 to the power minus 3. And it is smaller than 10 to the power minus 2. See, always here and here there should be one number difference. 0 and 1, 0 and 1, 4 and 3, 3 and 4. Okay. So, minus 3, minus 2. So this is 0.001, this is 0.01. It is closer to which? It is closer to this. It is closer to 0.001 than it is closer to 0.01. If it had been, number had gone beyond 5, then it would have been the other way around. So then all the grandeur is 10 to the power minus 3. It is closer to this number than it is to that number. Okay. So now we turn the page, and I have two more examples, again of one negative number. So here you have minus 0.06. Whenever you have minus, then obviously this side, that minus means you are on the left of the zero line, this side, and therefore you have to be a little careful. Minus 6, this is minus 6 into 10 to the power minus 2. That's the scientific notation, no problem there. Then when we do the encadrement, it's minus 6 into 10 to the power minus 2. It is bigger than 10 to the power minus 3 and smaller than 10 to the power minus 2. And here it is closer to 10 to the power minus 3 because it's minus 6. So it is, or the grandeur is 10 to the power minus 3. Here you are rounding down. Minus 6, you are taking a smaller number because it is closer to the smaller number than to the bigger number. Think of it that way. This is a smaller number, that is a bigger number. Which number is it closer to? Similarly here, every one of these, this is a smaller number, that is a bigger number. Which number is it closer to? So that is the number you take. Okay, so the last example that I do here, we have 650,000, that is 6.5 into 10 to the power 5. So the smaller size is 10,000, the bigger size is 1 million, and it is 650,000. 6.5 into 10 to the power 5. It is obviously closer to 1 million than it is to 100,000. So you get 10 to the power 6 here. Now, this is your homework. I've given you these numbers. I will send you this as a photo later on, so you don't need to do it from the video. I will take a photo of this page and send it to you separately. So this is what you have to find out, the grandeur of all these numbers starting from 785 and ending with minus 100. Okay. So now I'll tell you the answers to this one. 10 you cannot, 10 is, here it will be 10 is 1 into 10 to the power 1. Here you don't need to do any encadrement because it is already in a power of 10. So the order of magnitude is very simply 10 to the power 1. Similarly you do for 100 and minus 100. Okay. Because these numbers are already powers of 10. All the others are not powers of 10. Okay, so now we come to this one problem which is there in the next set of problems we will do. 67. On considère les nombres m est égal à 37,209,540 et n est égal à 0,0067. Déterminer la notation scientifique de m puis de n. So that is very simple. M is this. It is 3.720954 into 10 to the power 7. N is this. N is that. 6.17 into 10 to the power minus 3. Correct? Okay. Then they say, donnez un ordre de grandeur de m fois n, puis de m sur n. Now m fois n, you don't first find out the ordre de grandeur de m, then of n, and then multiply. First you do the multiplication, and then you find out the ordre de grandeur of the result. Similarly with the division. So let's do that. M fois n est égal à this number, I've copied it from there, into this number, I've copied it from there. Multiplying two numbers in scientific notation, it's better to multiply this into this and this into this separately. So 6.17 into 3.7 gives me 22.95. 10 to the power 7 into 10 to the power minus 3 gives me 10 to the power 4. So this is the number. This is m into n, but it's not in scientific notation because there are 2 digits before the decimal. Let's turn it into scientific notation. And there we get it, 2.29583 into 10 to the power 5. So now we do it all the grandeur of this. We take a shortcut. We don't do the bracketing and all that, but we realize that this is closer to 10 to the power 5 than to 10 to the power 6. So all the grandeur, the m fois n est égal à 10 à la puissance 5. Let's do the same with the division. M sur n, again m et n on a déjà en notation scientifique. When we divide it, we'll get 3.72095 divided by 6.17 into 10 to the power 7 minus minus 3, so it will become 7 plus 3. So this gives us 0.603 into 10 to the power 10. This is not in scientific notation, so let's put it in scientific notation. We get 6.03 into 10 to the power 9. Here we are multiplying by 10 to get this, so we have to divide by 10 to get that. So this is our number in scientific notation, m over n. Then you can see, if you bracket it, that 6 is closer to the next 10, 6 is closer to 10 than it is to 1. So this will become 10 into 10 to the power 9. And or the grandeur, the m sur n est égal à 10 à la puissance 10. I hope you have understood this. Replay it if you like. And that is the topic for the video. That's where the video for today ends. Now the next few chapters will have a bit of this. If you have time, you can look at this particular problem, which is number 69. It's red on over a yellow background. So this means this is a worked out problem. The example, the answer is at the back of the book. You can consult that to see how they do it. But in that answer, they do it in both way, or the grandeur this way as well as this way. You can ignore the first type for each one of those numbers and just make sure you got the second type correct here. Okay, so now this is where I'll stop the video. I will take a photo of this page and put it up on the web, not on the web, on the group, so that you can solve it, and that will be the assignment for today. Okay, I stop here.